Neo, welcome to the Matrix. The Matrix is all around us. It is what we see. It is what we breathe. The Matrix is a CCML video contest. Are you ready? Do you want to solve the CCML video question? Then take the red pill. Do you want to not solve the CCML video contest and remain unenlightened? Then take the blue pill. Wise choice.
If A is the matrix 0, 1, 0, 0, determine A to the 100th power.
When we raise the matrix to the 100th power, we simply multiply it by itself 100 times. Let's begin by multiplying it by itself just once, or squaring it. Upon doing so, we find that we get the matrix 0, 0, 0, 0. Therefore, no matter what we multiply this matrix by, including the original matrix, we get the 0, 0, 0, 0 matrix in return. Therefore, the original matrix to the 100th power is simply 0, 0, 0, 0.
I have solved the Matrix. Not yet, Neo. We're not done. The Matrix has reloaded.
If B is the following matrix, determine B to the 100th power.
This problem is similar to the last problem. We are given the matrix 2, -1, 1, -2, 3, -2, -4, 4, -3. We apply the same strategy and multiply it by itself. It turns out that we get the exact same matrix. Let's do the same thing again. We find that, again, the same matrix appears. This means that if we raise the matrix to the 100th power, then we really are just multiplying the same thing over and over again. We get the same result every time, and in the end, get the original matrix 2, -1, 1, -2, 3, -2, -4, 4, -3.
Neo, now it's time for the final part in the trilogy. Matrix Revolutions. It will be a revolutionary problem.
Given two matrices, C and C to the n, determine n plus y plus c.
We apply the same strategy and find a different pattern. When we square the matrix now, the rightmost term increases by 1. Multiplying again, we find that the rightmost term again increases by 1. The middle column, row, and left bottom corner spots, made up of zeros, will continuously stay at 0, and the left top box and the right bottom box will always be 1. The rightmost term seems to increase by 1 every time. We define this term as x, and plug this into the matrix. We find that the upper rightmost box results in x plus 1. X therefore increases by 1 every time you raise the power of the original matrix by 1. Through induction, if you raise the power of the matrix to 50, you would be adding 1 to itself 50 times to get 50, the number we want in the upper rightmost corner. Therefore, n must be 50, y must be 0, and z must be 1. Our final answer is the sum of these, or 51.
Neo, you are almost done. Just one more problem, and you will have solved the matrix.
Find e to the x, if x is the given matrix, using the definition provided.
We notice that the matrix 1, 0, 0, 0, 0, 0, 0, 0, 1 is similar to the one in problem 3. However, instead of the 1 in the right corner, it has a 0. Therefore, like problem 1, determine the right corner will always be 0. We know therefore that no matter what power we raise it to, we will return the exact same matrix, which makes it like problem 2 in that we can simply ignore the k in the numerator. However, we cannot disregard the k in the denominator. We know that when we divide a matrix by a scalar, or in this case, k factorial, we simply divide each element by the scalar. We can then simplify the matrix to 1 over k factorial, 0, 0, 0, 0, 0, 0, 0, 1 over k factorial. Then, due to the definition of e to the x that we are given, 1 over k factorial becomes e to the first power, or e. Therefore, our final answer is e 0, 0, 0, 0, 0, 0, 0, e.
Solve the matrix. Thanks for watching.
America.